يجري الآن تسجيل هذه المكالمة.
Okay, assalamu alaikum everyone. Welcome to our second and last revision part. Today we're going to cover the concept of filter circuits and Fourier theory, including the Fourier series and Fourier transform, okay? So as usual, I will start to give you examples. I'll show you the solution. If you have any question, feel free to stop me and ask about it, okay? I'll try to put my answer in as many steps as possible so it will be clear for you. Okay, let's start with the first question in part 2, which is consider the filter circuit in the figure below where R is equal to 10 kilo ohm and C is equal to, thank you, 50 microfarads. Can you determine the cutoff frequency omega C? So you're told this is a filter circuit. What is the cutoff frequency of that filter? You're not told what type of filter it is or how to calculate. So in that case, you only know that the output is V2 and the input is V1. Therefore, you have to first figure out what is the transfer function, and based on that, what is the cutoff frequency. So we're going to use something we learned last week, which is, we learned a long time ago, which is the voltage divider rule, that V out, that the transfer function or the gain, H, is equal to V out, which is V2 over V in, which is V1, which is equal to ZC over R plus ZC, which is the total, which is equal to 1 over SC divided by R plus 1 over SC. So far, are we following? Okay, so just to simplify it, you can unify the denominator, so it becomes SCR plus 1 over SC. And you'll notice that these two will counter each other out, so you'll end up with the transfer function equals V2 over V1 is equal to 1 over SCR plus 1, right? This looks like the normalized form of a filter transfer function, right? Where we know that we have S over, or J omega over omega N, or omega C here in that case, which means that the cutoff frequency is equal to what? So this is basically 1 over S over 1 over CR plus 1. And that's in a normalized form, which means that the cutoff frequency omega C is equal to 1 over CR. Make sense? Was it clear? No. Okay, where did we stop? إلى هنا أوكي؟ طيب. إحنا مش قلنا normalized filters بتكون بصيغة إنه ال added number here is 1 so that the cutoff frequency will always be 1. But the actual cutoff frequency is here. يعني هي فعليا مفترض تكون 1 على J omega plus 1. But when you normalize it, it becomes omega over omega C عشان هنا تكون 1. فإذا الأوميجا C هي الرقم اللي هنا صح؟ طيب 1 over omega C is equal to CR. إذا omega C is 1 over CR. Make sense? طيب. This we got the general form. Here we have values of C and R. So all you have to do is substitute. 1 over C come 50 micro, 50 times 10 power minus 6 times R, which is 10 kilo. So 10 times 10 power 3. And then you can calculate it to find the cutoff frequency in radians per second, which is 10 power 4, 10 power minus 2, which is almost omega C is equal to 2 radians per second. Okay. The second part of the question tells you
Excuse me, miss.
Yes.
For this, the question one, do we have to write all these formulas, or we can only use the last formulas and
If you only write the last formula, how would I know where you got this? You need to write the derivation formula. Otherwise,
mm,
make the minor mistake, you will not get any mark.
okay,
Okay?
okay,
So this to show your understanding, so you can get even partial marks if you make a mistake. Right.
great.
Now we have to, and then the second thing is you'll notice that part 2 depends on part 1. When you say identify filter type, we'll have to go back to this part here, which you already derived in part 1. So if you look here, what is the filter type, and justify your answer. So your justification would be that, okay, the filter transfer function V2 over V1 is 1 over SCR plus 1, which we derived in part 1. And then we can plot the gain of the filter. So step 2, plot the gain of the filter. So the gain, both plot will be as follows. You have only one pole, right? There is no zeros. Only one pole, value of S, that will make the denominator 0, which is pole at 1 over CR, which is the curve frequency that you've calculated in part 1. So if you plot omega versus gain in decibels, you'll have only one pole at 1 over CR. And this will be 0 decibels, and this will be dropping, right? If you look at this is in decibels, but if you look at it in regular frequencies, it looks like this with a cutoff frequency at 1 over CR and a gain of 1 because it's a factor, right? So what type of filter does this look like?
Low pass.
Low pass filter. So this is the justification, and the answer is this is low pass first order. And if you look at the circuit, is it passive or active? Active is one with amplifiers. Passive is without. So this is passive or active? Passive. Passive filter. So this is the type of filter. It's first order because if you look here at this equation, it is first order. It is low pass because if you look at the transfer function or the gain, it looks like a low pass filter. And it is passive because if you look at the circuit diagram here, there is no operation amplifier, so it's passive. So your answer must have all three specifications. It's order, whether it's passive or active, whether it's low pass, high pass, or band pass filter. Clear? So this is the second part of the question. The third and final part is, well, if the input was 10 cosine 3t plus 60, can I determine the output? So this is very important because we know that the gain is equal to output divided by input, right? Therefore, the output V2 is equal to the gain multiplied by the input, correct? Let us consider the phasors of this. But first, let's try to find the phasor of it. We have H equals to what? From part 1 and from part 2 is equal to what? 1 over SCR plus 1. H of S is equal to 1 over SCR plus 1, which means H of J omega is equal to 1 over J omega CR plus 1. We're following? From here, can I get the magnitude and angle of H of J omega? So the magnitude of H of J omega is equal to 1 over the magnitude of J omega CR plus 1, which is equal to 1 over square root of omega CR squared plus 1 squared, right? Do we know omega value from the question? Omega is 3. So 1 over the square root of 3 times C and R. We already have their values from the first statement. 50 micro and 10 kilo. So just write it here, times 50 times 10 power minus 6 times 10 times 10 power 3, all squared plus 1. So can I get the value of the gain? Anyone with a calculator? And then can I get the value of the angle of h of j omega, which is the angle of 1 minus the angle of j omega CR plus 1, which is equal to 0 minus tan inverse the imaginary part, which is omega CR, over the real part, which is 1, right? And we also have the values for that. So we'll substitute. Okay. Huh? No, imaginary over real. احنا لأنه كنا كاتبين j الأول بس part multiplied by j first. Okay? Which is equal to minus tan inverse 3 times 50 times 10 power minus 6 times 10 times 10 power.
Excuse me.
Yes,
It will be recorded this
it is being recorded right now.
because we cannot be in live now.
Okay, it is recording. Right now, this is being recorded.
Okay, thank you.
Okay, so we have the magnitude and we have the phase of h of j omega, right? Which is, let's see, did I calculate them?
0.15.
I got it to be, how much?
0.15.
0.
Without tan.
No, I'm here for the gain for this one. Can someone, do you have a calculator? Anyone? You came to class without calculators, okay.
Minus 8.530.
Okay, just a moment. Let's see. So the magnitude here is what? Okay, I'm gonna put it in green just to double check it later. 0. 0.24. This is what
56.31. Minus means minus 56.
we're getting conflicting answers. And I forgot my calculator. It's okay. Okay. 3 times 50 times. I got 0.55. You all get that? Online, did you get 0.55?
Yes, first one 0.554.
0.554, yes. So almost 0.55, that's the magnitude. And then the angle would be tan inverse. What did you get? So it's
Minus 28.8.
okay, let's check it. I don't even have the inverse tan.
No, sorry.
Minus 56.3.
56.3? Okay. Let me see.
Yes, minus 56.3.
Okay. Minus 56.3 degrees. Okay, good. So h of j omega phasor is 0.55 e power minus j 56.3 degrees. Based on what? Based on these two values, right? We have h of j omega, and then now we want to have v1 phasor. The phasor of v1 is what? 10 e power j60, right? So we can say that v1 phasor is equal to 10 e power j60 degrees. 60 degrees. Therefore, let's call this equation 1. Let's call this equation 2. And let's call this star. We are going to substitute the values for h and v in to calculate v2. So substitute 1 and 2 in star. We'll get that phasor of v2 is equal to 0.55 e power minus j 56.3 times 10 e power j 60 degrees, which means it's equal to what? 0.55 times 10 is 5.5 e power j minus 56 plus j 60 will be what? E power j what?
65 point plus
3.7, right?
3.7.
So this is v2. But the question is find v2 of t, not v2. So all we have to do is just do the opposite for the phasor. Because we already know that omega is equal to 3, we can say that, therefore, v2 of t will be equal to 5.5 cosine 3t plus 3.7 degrees. And that would be the answer that we need. Clear? So if you notice, to the person who asked, do we need to do all the steps in part 1, you'll notice that we had to use the steps to solve part 2 and part 3. Clear? Any questions so far? Okay, so in a very similar manner, let's save. In a very similar manner, let's do question 2. It's very similar, but the circuit is just flipped. Instead of the output being out of the capacitor, now it's being out of the resistor. Yes, it will be, because we know that, but let's do the calculation first.
دكتورة يعني
Yes.
هذا السؤال نفس اللي فوق بس بالبرامج صح؟
Yes. مش parallel، نفس اللي فوق، بس الاوتبوت في ال R not في C.
أوكي.
Okay. So it will be the same process. We'll have to just find what is the transfer function H is equal to, which is V2 over V1. And in this case, it will be the resistor divided by the resistor plus 1 over SC. See, there is a question. Yes, Muhammad, I see there is a raised hand. What's your question? Okay. We'll do the same steps we did before. Unify the denominator, so it becomes SCR plus 1 over SC, which means it's equal to SCR divided by SCR plus 1. We did this so many times before. I think it's clear for everyone so far. Then all you have to do is repeat the same thing we did before. So if you look here, you notice we have 1 pole at, okay, actually this is for the next step. You look here at the denominator, you'll notice that the cutoff frequency omega c based on this normalized form, same way, is 1 over CR, which is equal to what? We have the value of R, we have the value of C. 1 over C is equal to what? 60 micro, 60 times 10 power minus 6 times 5 kilo, so 5 times 10 power 3, which is equal to what? حلو. الأوميجا C من وين جاء؟ أوكي حلو.
3.33.
Let's start. Okay, I'll ask you for the answer to repeat it again after this, okay? For the person online who's giving me the calculations. إلى هنا الخطوة دي واضحة؟ حلو. طيب إذا اطلعنا على الخطوة دي، القانون بيقول إنه إحنا لما نقارن فلاتر أو لما نحسب ترانسفير فانكشن بنحسبها بالنورماليزد فورم، اللي هو التيرم اللي فيه الإس بالإضافة لواحد. صح؟ بحيث إنه وركز على المقام، على ال characteristic equation اللي هي معادلة المقام، بتكون دائما بصيغة j أوميجا على أوميجا n plus 1. حلو؟ الجي أوميجا دي هي نفسها الأس اللي هنا، صح؟ والأوميجا n هنا بتمثل الكت اوف فريكونسي. يعني احنا حاولنا إنه يكون زائد واحد. ليه؟ عشان لما نرسم البوت بلوت هتلاحظ إنه الجين بيساوي واحد to normalize it، بحيث إنه بغض النظر عن الأوريجينال كت اوف فريكونسي الجين يكون 1 والكت اوف فريكونسي يكون ثابت. فمن هنا if you compare، يعني considering that this is the normalized form، فإذا الرقم المضروب في الاس سي واحد على الرقم ده هو الأوميجا سي. So omega c will be equal to 1 over CR, which is equal to 1 over 60 micro, 60 times 10 power minus 6 times R, which is 5 times 10 power 3. Yalla, you've already done the calculation. Can you give it to me one more time?
3.33.
3.33. Did we all get the same answer?
But we are getting 73.3. 333. 333.
3.33. We're all getting 3.33. Confirmed? Okay, so we'll leave it there. So this is omega c. Moving on to part 2. You'll notice it's the same question, it's just a minor difference in the circuit itself. Okay, what was the filter type? So if you look here at the transfer function that we've calculated here, H is equal to SCR over SCR plus 1. And if you want to plot the gain for this circuit, plot gain using both plot, you'll notice that I have a 0, right? A 0 at what? A value that will make the numerator 0 at what? At origin. When S is equal to 0, we have a 0. So we have a 0 at origin, and we have a pole at 1 over CR. Which means that if I'm to plot omega versus gain in decibels, a 0 at origin means a line crossing the axis at 1. A pole at the origin means a line that has a stable 0 decibel gain and then starts to drop at the cutoff frequency. So if we combine these two, we'll end up with a line that continuously goes until it reaches to the point of 1 over CR and then stabilizes at that value, right? And this type of filter is what? High pass filter. So what we're looking at is a high pass. How much is the order? Is it first order, second order? High pass, first order, passive filter. Clear? Okay. Now, finally, the last step, which is very similar to what we did before. If you have this input, what would be the output? So we'll start with the gain, HSCR over SCR plus 1. H is equal to SCR divided by SCR plus 1. That is H of S. Enhance this a little bit. This is H of S, which means that H of J omega is equal to J omega CR over J omega CR plus 1. And then all you have to do is repeat the same process. We will use the concept that, let me do it here. V1 should be equal to H times, sorry, V2 should be equal to H times V1. But I'm going to use phasors. So step 1, to find the phasor of H of J omega. The phasor of H of J omega is equal to the magnitude of H of J omega and the angle of times, sorry, e power j, the angle of h of j omega, right? So we have to find the magnitude and we have to find the phase of the system. So all I have to do is just substitute values. I know the value of c, I know the value of r, and I know the value of omega, right? What is omega? 5, given in the question. Omega is 5, and c and r are given here. C is 60 micro and r is 5 kilo. So I'll substitute. We can say that h of j omega is equal to j 5 times 60 micro, so 60 times 10 power minus 6 times 5 kilo, so 5 times 10 power 3, all divided by j 5 times 60 times 10 power minus 6 times 5 times 10 power 3 plus 1. And the magnitude is this, right? The magnitude of the numerator will be the same value without the j, right? Because we'll take the imaginary part squared and then take the square root of it. So it will be 5 times 60 times 10 power minus 6 times 5 times 10 power 3. Divided by, let's calculate it just to make our writing a little bit less crowded. Can someone confirm to me what is the value of 5 times 60 times 10 power minus 6 times 5 times 10 power 3? So this is 10 power minus 3. 5 times 5 is 25 times 60. So I think this will be 1.5. So 1.5 times 1j times 1.5 plus 1. And then the magnitude will be the imaginary squared, the real squared, the square root of them. Correct? Right? And then you can calculate it, which would be, can you please confirm it? 0.83. And then we can find the phase angle.
Teacher,
Yes?
why we are making here قدر تربيعي؟
لأنه بنحسب القيمة المطلقة، عايزين نحسب قيمة العدد، وعدد ده عدد مركب فيه جزء حقيقي وجزء تخيلي، صح؟ ففي الأعداد المركبة magnitude of a number x is equal to square root the real part squared plus the imaginary part squared.
لكن ليش ما استخدمناها في القيمة الفوقية؟
الفوق لنا فيها فقط الإيماجينري، ما فيها ريل، صح؟ يعني إحنا استخدمناها فعليا، لكن هي عبارة عن جذر 0 تربيع زائد الإيماجينري بارت سكويرد اللي هو الرقم. أوكي؟ وضحت؟
طيب.
أوكي. طيب. The magnitude will be the angle of J 5, let's call it J 1.5 اللي هو الرقم اللي في البسط هنا ناقص angle J 1.5 plus 1, right? زاوية البسط ناقص زاوية المقام. طب البسط is purely imaginary and positive. إذن كم الزاوية؟ Remember the angle is based on the real imaginary plane. So if the number is purely imaginary and positive, it's here, which means that the angle is what? 90 degrees. فالجزئية الأولى it's 90 degrees minus the angle of the second part, which we follow the rule of tan inverse imaginary over real. Okay? Which is equal to what? Tan inverse 1.5 is what?
minus 56.331.
56. Okay, 90 minus 56.31, which is equal to what? Yeah, 33. 33.679. 69, okay, degrees. Which means that now we can write the magnitude, or sorry, the phasor of h of j omega is equal to 0.83 at e power j 33.69. Clear? So I'll call this equation 1. And then we'll find the phasor of V1. Just copy V1 here. If this is V1, can I get the phasor of V1?
Yes.
What-
Phasor V1 is equal.
First step, remember, الphasor is related to cosine,
Sign there, not phasor.
right? So step 1, convert the sine to cosine. احنا عارفين الفرق بين السine والسine 90 degrees, right? So all you have to do is just convert this. V1 of t is equal to 20 cosine 5t plus 30 degrees minus 90 degrees, right? Which is equal to 2 cosine 5t minus 60 degrees. So this is V1 of t, which means that the phasor of V1 is equal to 2 e power j minus 60, which is 2. And then we can substitute these to get V2. V2 phasor is equal to H phasor times V1 phasor, which is equal to 0.83 e power j 33.69 times 2 times e power minus j 60 degrees, which is equal to what? 1.66 e power j minus 26.3. Okay, so this is V2 phasor, and we want to find V2 of t. All you have to do is just convert it back to a cosine waveform. So V2 of t is equal to 1.66 cosine omega t, and omega is equal to what? 5 minus 26.31 degrees. And this is the answer that we're looking for. Clear? The steps are clear for you? The calculation is clear? Okay, so that concludes question 2. Now, ليه حاولنا كوساين؟ لأن السؤال كان find V of t, not find V phasor. احنا حاسبينها كفيزر كنا. So we have to convert back to cosine to get V of t. Okay, let's look at a different. If you had,
بس ليش اخترنا 90؟
you'll add again. احنا ما اخترنا 90 لحظة. I'll get back to you online, just a minute. You'll just multiply by the gain of the amplifier. So H will be the gain of the amplifier multiplied by the transfer function. Okay, about 90. So here, this 90 is relevant للبسط هنا. هنا it's purely imaginary, ما فيه real part, صح؟ يعني احنا عندنا رقم عبارة عن بسط ومقام. البسط purely imaginary والمقام فيه imaginary و real. Purely imaginary means it's here in the axis and it's positive, وبالتالي الزاوية 90. Clear? If it was negative, إذا كان هنا و imaginary كانت حتكون الزاوية سالب 90. Clear?
يس مس كلير. شكرا.
Okay, so now let's move on to question 3. To answer your question, so this is similar. Here we have an active filter. It says consider the active band, the active filter, not band pass, the active, this is low pass. The active low pass filter circuit here. Can you derive the transfer function of this circuit? Your exact question, right? So if you look here, this is a low pass filter, right? This is a gain sector, right? This is an amplifier with a gain. This is a second low pass filter. So the overall gain V2 over V1 will be the gain of stage 1 multiplied by the gain of stage 2 multiplied by the gain of stage 3, right? So what is the gain of low pass filter? We already established it. We've calculated here, but in the exam, don't say I've answered it in part 1. You'll write it here, right? So say that this is, let's call this, for example, just to make it a bit more organized, gain 1, gain 2, gain 3, that we have 3 stages. So the overall gain would be gain 1 times gain 2 times gain 3. We know that these are 2 low-pass filters with the same values of components R and C, right? So gain 1 is equal to gain 2, equal to what? A low-pass filter gain, which is 1 over SCR plus 1. And this you can derive by just taking this and using the voltage divider rule, right? And then let's look at the amplifier bit. If you look at the amplifier, is it inverting or non-inverting? Which means non-inverting, right? However, for a non-inverting amplifier, gain of non-inverting amplifier is equal to 1 plus R feedback over R input, right? But if you look here, the feedback resistance is what? 0. It's a shortcut, right? And the input resistance is infinite, right? Which means the gain is equal to 1. It's a voltage follower, which means that overall the gain will be what? V2 over V1 is equal to 1 over SCR plus 1 times 1 times 1 over SCR plus 1, which is basically 1 over SCR plus 1. Do you agree with that? So this is the transfer function h of s. خلاص, done. Now, can we determine the order and the nature of the filter? Okay, thank you. We call this a voltage follower. Okay. Can we determine the nature and order of the filter? Order is obvious. It's second order. Okay. We've already established that it's what? If you look here, it has 2 poles, both at 1 over CR, right? So if you are to plot it at 1 over CR, it will start to drop sharply with minus 40 decibels per decade, right? So this is what? Low pass filter, right? Is it active or is it passive? Active, because it has an amplifier, right? So it's active, it's low pass filter, it is second order, okay? Let me write this in a bit better handwriting. So the second order low pass active filter with the cutoff frequency, or we have 2 poles at 1 over CR. Okay. Can you determine what resonant frequency? I changed this to what? Just a moment. Undamped. Okay. Can you determine the undamped natural frequency and the damping ratio of the filter? So this is less about filters and more about second order systems. So what go function? It is what? the transfer function h of s is equal to 1 over SCR plus 1 squared, right? And if you remember when we were studying damping ratio, undamped frequency, damped frequency, all of this was based on the standard equation for a second order system, right? And we said that the standard equation for the second order system is in the form of what? Omega n squared times k divided by s squared plus 2 zeta omega n s plus omega n squared. So this is the standard form of a second order system, right? And here you're asked to find the undamped frequency, which is omega n, and the damping ratio, which is zeta, right? So you have this equation and you have this equation, and all you have to do is compare them, and by comparison you can derive the value of omega n and the value of zeta, correct? So all we have to do is just take the transfer function and try to restructure it into a similar format. So I'll just have to break this power, expand the second order expression. So we can say that this becomes h of s is equal to 1 over SCR squared plus 2 times SCR plus 1, right? This is a quadratic expression expanded, which is equal to 1 over S squared times CR squared plus 2SCR plus 1. Still not the same, right? I want the S squared to be isolated so that it can be comparable, and I need it to be in the same format. The coefficient of S squared must be 1. How do I get rid of this CR so that the coefficient of S squared can be 1? تحتاج اتخلص من CR صح؟ بحيث انه الصيغتين يكونوا متشابهات واقدر اقارن بينهم. All you have to do is take CR squared as a common factor. What happens when you do that? It becomes 1 over. طلع CR squared. Here we'll have S squared, CR squared plus 2SCR plus 1 divided by CR squared by CR squared by CR squared. Okay? And as if we multiplied and divided by SCR all squared. So these two cancel each other out. And this becomes what? 1 over CR squared, all divided by S squared plus CR, and the squared go with each other, صح? You get 2 over CR S plus 1 over CR all squared. This is H of S, صح? This now, we can call this 1, we can call this 2, we can compare 1 and 2 now to get zeta and omega n, right? Correct? يعني بعد كده ممكن أقارن الصيغة الأخيرة بالستاندرد فورمات. طيب what will be omega n? Comparing the constant term, the characteristic equation, we can say that omega n squared is 1 over CR squared. إذن omega n is equal to 1 over CR. Okay? And then we can compare the second term, the coefficient of S. What do we get? 2 times zeta times omega n is equal to 2 over CR. Meaning zeta 2 بيلغوا بعض صح؟ Zeta is equal to 1 over omega n CR. Well, omega n is 1 over CR, is 1 over CR times CR. Zeta is equal to, what does that tell you about the system? Remember we said the damping ratio tells you about the stability of the system, damped or undamped or critically damped. Or if zeta is equal to 1, the system is undamped, which means it will continue oscillating without reaching a steady state value. So this is zeta, this is omega n. Clear? Any questions so far? Are we sure? Online, do you have a question? It means the system is, if zeta is 1, undamped. If zeta between 0 and 1, critically damped. There is overdamped, underdamped. So zeta tells you how the system behaves. Does that make sense? Okay. Where am I standing at? Just a moment. Okay. Where am I? Okay. 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 Any questions so far? Where am I at? Okay. Now let's move on to the Fourier theory. Okay. So here, I kept it simple. A periodic triangular signal x of t of period t equals 8 seconds is defined as x of t is equal to 2t when t is between -2 and 2 and 0 otherwise. Can you determine the Fourier coefficients a0, an, and bn of this function? طيب, let's start with the definition of the function. في information already given to us. T is equal to what? So this is a very useful information. Let's keep it. The period is equal to 8. This is what the function looks like. Let's visualize this function. Let's see what x of t looks like. This is t. Let's plot it. Between -2 and 2, so let's say this is -2, this is 2. X of t is equal to 2t. يعني at -2 it's equal to what? -4.
-4.
Which is somewhere here. Let's assume this is -4. At -1 it will be equal to what?
-2.
Okay, let's assume it's somewhere here. At 0 it will be equal to what?
0.
At 1 it will be equal to what?
2.
2, so 2 here. And at 2 it will be equal to
4.
4. Let's assume it's somewhere 2 here. So basically, it looks like this. And then otherwise it's 0, which means from here onwards, it drops to 0, right? This is what it looks like. So this is x of t. Can I find the Fourier coefficients? A0, an, bn. We have all the three formulas for A0, for a, and for bn. For example, A0 is equal to what? 2 over t, the integral between t naught to t naught plus t x of t dt. This is the general formula, right? Which is basically the integral over one cycle of the period, which will be equal to what? 2 over, we know t is equal to what? 8. And if I want to integrate, what would I integrate over which cycle? From where to where? Now notice it's equal to 8. The period is 8. So realistically, the period starts from -4 to +4. But from -4 to -2. And from 2 to 4, the value is 0. From -2 to 2. And the value of x of t is what? 2t dt is equal to what? 2 over 8 is 1 over 4. The integral of 2t is what? 2t squared over 2. From -2 to 2. These 2's cancel each other out. 1 over 4. And then we do t squared. 2 squared minus -2 squared. Which is equal to what? 0, right? Does that bring your attention to something? when you try to calculate a of n, a of 0, it was 0. Now, the other option is we can go for a of n, which is equal to 2 over t, the integral from t naught to t plus t naught, x of t cosine n omega naught t dt. This is the general formula. And it will be a lengthy calculation. But if you look at the function x of t, do you notice something about it? Is it being odd or even? Do you notice that this function is mirrored? It's odd, right? And a0 is 0 because it's odd. So therefore, without further calculation, a of n is equal to 0 because x of t is odd, right? So I don't have to do the calculation. You can do the calculation, it will take you a long time, but at the end you'll end up with 0 similar to this one. I did a0 just to show you that it will be 0, but because this is brief, when we do an, it becomes lengthy. So a of n is 0. So it's very important to pay attention to any shortcut that can help you reduce the calculation that you have to do. Finally, let's move on to b of n. The formula for b of n is 2 over t, the integral between t0 to t0 over plus t, x of t sine n omega naught t with respect to t. This is available in the formula sheet, okay? All you have to do is now substitute values and perform the integration. What is the values that we will substitute? We have to look at period, integration limits, value of function. Okay, these are things we can change and look at what the actual values we have, which means b of n is equal to 2 over, the period is what? 8. And the integral becomes between minus 2 to, and x of t is equal to 2t sine n omega naught t dt, correct? These two can bring out, right? So it becomes 4 over 8, which is 1 over 2, the integral from minus 2 to 2 t sine n omega naught t dt. Okay? This will be a little bit lengthy. Bear with me. Why? Because if you look here, t times sine n omega naught t, this is the integral of two functions multiplied by each other. تكامل ضرب دالتين, right? And this is the rule that we will use. And I don't think it's available in the formula sheet, but the rule is if you have the integral of u times dv, two functions, then this integral is equal to u times v minus the integral of v times du. Remember that rule? So this is what I'm going to use here. I'm going to assume that t is u and this is dv. Okay? So let's write our statements. We're going to let u equals t, which means du is equal to dt, right? And then I'm going to assume that dv is equal to sine n omega naught t, which means v is equal to what? The integral of a sine, which is minus cosine n omega naught t divided by n omega naught. Is this first step clear to you? So I took my assumption that u is equal to t, which means the derivative of u is equal to the derivative of t. I took the assumption that I'm assuming that the sine is the d of v, the derivative function v, and to find v, I have to integrate. Then I'm going to substitute in the formula, in the equation of the integral of two multiplied functions, which will be equal to what? We'll say that, and I'm only focused on the integral part, the integral from minus 2 to 2 of t sine n omega naught t with respect to t will be equal to u times v. So u is what? T times v, which is minus cosine. So minus t cosine n omega naught t over n omega naught. That's the first term. Minus the integral of v times du. V is what? Minus cosine n omega naught t over n omega naught. Du is what? Okay. Keep in mind that this is still definite integral. So here we still have the limits from -2 to 2, and here we still have the limits from -2 to 2. Minus is plus, right? Let's use a different color to show that they canceled each other out. This negative cancels this negative out. Okay? Now it becomes a simple integral. What is the integral of a cosine? Now it becomes simple, so it's equal to minus t cosine n omega naught t over n omega naught from -2 to 2 plus the integral of a cosine is what? Sine n omega naught t over, we already have n omega naught, and then from the integral I'll have another n omega naught, which means n omega naught squared, with limits from -2. So far we clear? Now we have to substitute upper limit minus lower limit. So I'm going to do it one by one. Let's start with the first term and substitute. We obviously will substitute in place of our variable, which is t. So it will become, and also I have a t here, okay, minus 2 cosine n omega naught 2 over n omega naught. That's the upper limit. Minus, so that's the upper, use different color. That's the upper limit. Minus the lower limit, which is minus 2 cosine minus n omega naught 2, which is basically, let me just rewrite it so it will be clear to follow for everyone. N omega naught minus 2 over n omega naught. That is the lower limit, right? I'm just focused on this bit now, which is this bit. Okay? Plus, still have the second term. Let's use green for that, just to, so we have now this bit. Okay? Okay. Here we have the upper limit is sine n omega naught 2 over n omega naught squared. That is upper limit, right? Minus the lower limit, which is sine n omega naught minus 2 over n omega naught squared. Yeah? Then let's look at it. Okay. Minus 2 plus 2. Cosine is an even function, so cosine x is equal to cosine minus x, right? So cosine minus 2 n omega naught is equal to cosine plus 2 n omega naught, right? Yes? This last step is here, in this minus 2. We can convert it to positive, right? Because we know that cosine x is equal to cosine minus x. So this becomes plus, right? Which means we have minus 2 cosine and omega naught 2, minus 2 cosine and omega naught 2, right? So it's the same term repeated twice, both in negative sign, which means this becomes minus 4 cosine and omega naught 2 over n omega naught. Do you agree with that? And then we move on to the next term, plus Cosine is an even function. Sine is an odd function, which means sine x is equal to minus sine minus x, right? So minus sine minus n omega naught 2 is also equal to this, right? Make sense? So if you look here, it becomes again the same term repeated, sine n omega naught 2 over n omega naught squared. So we have 2 of it, so 2, we're using green for this one, 2 sine n omega naught 2 over n omega naught squared. Yes, is there a question? So far we could. So far is it good for everyone? Okay, now we know that the value of omega naught is equal to what? 2 pi over t. That's a rule. And we know t is equal to 8, which means omega naught here is equal to 2 pi over 8, or in other words, pi over 4, right? So here, 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 and here I can start replacing it by pi over 4. So we can say that it will be equal to minus 4 cosine n pi over 4 times 2 over n pi over 4 plus 2 sine n pi over 4 times 2 over n omega naught, n pi over 4, n pi over 4 squared. Yes? Which means this is equal to minus 4 cosine n pi over 2 over n pi over 4 plus 2 sine n pi over 2 over n pi over 4 squared. This is the integral. This is just the integral, but remember there was a bit here that I skipped. This. So I'll just add it at the last step. So I can say that therefore b of n is equal to 1 over 2 multiplied by this expression that we have, which is minus 4 cosine n pi over 2 over n pi over 4 plus 2 sine n pi over 2 over n pi over 4 squared, which is equal to over 4 over 2. This is minus 2 and this is 1. So b of n is equal to minus 2 cosine n pi over 2 plus sine n pi over 2 over n pi over 4 squared. And this is b of n.
Miss,
Yes?
are you sure we will solve all this question in 3 hours?
Come again?
Are you sure we will solve all this question in 3 hours?
Well, it's up to your preparation. Some people can. 70% of people can do that. If you want to be out of these 70, it's your choice. If you want to be of the 30 who can't, it's also your choice. Is it clear? Now, there's a lot of calculation. I understand. There's a lengthy calculation, but it's not challenging. It's not a impossible math. It's just following the signs and the symbols. And writing the steps gives me a chance to give you a mark on understanding. So even if you made a negative sign by mistake here, or you forgot to simplify something here, the steps kind of show me your thought process, which enables me to give partial marks. So instead of having, for example, 0 out of 10, you'll get 7 out of 10 for steps, or 8 out of 10 for steps. Does that make sense? So as long as you try to write the steps, it will go, okay? Because up till this point, the only thing here is knowing this formula, how to do the integration. From that point onwards, all this page is just me trying to simplify, and I'm putting it in so many steps. Even when I'm taking 2/4, I'm doing it in a separate step, just so it's clear for you to follow and to understand. Okay? So that will be like the -1 mark. So it will be clear, at least the steps are there, the calculation is there. Is it clear? Okay. Finally, it says find the first 3 non-zero harmonics. We already established that A of n is 0. So all of them will be dependent on B, right? So we can say that C of n, or sorry, A of n, I jumped to question 3. A of n is equal to 0, regardless of the value of n. B of 1 is equal to what? All you have to do is substitute n value here by what? 1. So it becomes -2 cosine pi over 2 over pi over 2 plus sine pi over 2 over n pi over 4 squared. Cosine pi over 2 is what? 0. Cosine 90 is 0. So this term is gone. And sine pi over 2 is, this is equal to 1. So therefore, B1 is equal to 1 over, this is also 1, sorry. 1 over pi over 4 squared. And you can calculate that to see what is the value of 1 over pi squared is. And then we move on to B2, which is equal to what? -2 cosine what? 2 pi over 2 divided by 2 pi over 2 plus sine 2 pi over 2 over 2 pi over 4 squared, right? 2 and 2 cancel each other out. 2 and 2 cancel each other out. Cosine pi is equal to what? -1. And sine pi is equal to 0, which is equal to what? Sorry, did I do? I want to make space here. -1 times -2 is 2. But okay, let's take this 2 and this 2. So it becomes B2 is equal to 1 over pi over 2, or 2 over pi. Hold on, why am I skipping steps? Yes. So this is B2. Okay? Let's find B3. B3 is equal to, let me just keep it here. Here. 2 -2. Okay, here. -2 cosine 3 pi over 2 over 3 pi over 2 plus sine 3 pi over 2 over 3 pi over 4 squared. Okay, 3 pi over 2. Cosine 3 pi over 2 is equal to 0. Sine 3 pi over 2 is equal to minus 1, which means that B3 minus 1 over 3 pi over 4 all squared. So these are the first three non-zero terms. B1, we have B2, and we have B3. Okay? Just a moment. Okay. Okay? Can you find the magnitude and phase from these to find C of n and theta of n? So we said B1, we said first C of n, this is the formula, is equal to square root A of n squared plus B of n squared. And we said that theta of n is equal to tan inverse B of n over C of n, over A of n, right? We have these formulas and they're available in the formula sheet as well. But A of n is 0, right? Which means C of n will always be square root B of n squared, or in other words, it's the absolute value of B of n, right? So C1 will be equal to B1, and B1 is what? 1 over pi over 4. One over pi over 4 squared, right? And then based on that, theta 1 would be equal to what? If if A is 0, it means it's based on the value of B, right? This represents A, this represents B. If A is 0, it means you're either positive B or negative B, right? If you're at the positive value, the angle will be 90 degrees. If you're at the negative value, the angle will be minus 90 degrees. So you have only two options, either 90 degrees or minus 90 degrees. So B1 was positive, right? Which means that the angle is what? 90 degrees. So all you have to do is just write here, theta 1 is 90 degrees. C2 is equal to magnitude of B2, which is 2 over pi. So here we have 2 over pi, which means that theta 2 is equal to, it's positive. B was positive, so it will be 90 degrees. C3 is equal to the magnitude of B3. B3 was minus 1 over 3 pi over 4 squared, which means that it will be 1 over 3 pi over 4 squared. But theta 3 will be what? Minus 90 degrees, because B was equal to minus 90. Clear? Okay. So that ends this one. Now it's good that it's odd, otherwise if it was even, then you would have had to also derive A of n, which is another 3-page. And don't worry, the exam book has, I think, 20 pages. So you can write as many as you want. Clear so far? Any questions? Let's see if I have anything left. Good? Okay, last question. Khalas. We're almost there. Hang in. Last part, which is Fourier transform. Fourier transform is direct. So here it says, determine the frequency spectrum x of omega of this x of t. This is straightforward. What happened? Okay. Because we know the formula. We know that x of omega is equal to the integral from minus infinity to infinity of x of t e power minus j omega t dt. This is the standard formula for x of, and it's available in the formula sheet. Again, you don't have to memorize it. So if you look here, we have two stages, right? From minus 0.5 to 0, there's a value, which is negative 1. And then from 0 to 0.5, you have a value which is positive 1. So all you have to do is apply the formula, but in parts, in two different ranges. From minus 0.5 to 0, x of t is substituted by minus 1. So minus 1 times e power minus j omega t with respect to t, plus the second range from 0 to 0.5 of 1 e power minus j omega t dt. And then all you have to do is just substitute. The integral of an exponential function is the same exponential, e power minus j omega t divided by minus j omega multiplied by minus 1, with a range of 0.5 to 0, plus the integral of e power minus j omega t over minus j omega from 0 to positive 0.5. And then all you have to do is substitute in place of your variable t your integration limits. So the first term will have, now obviously this negative and this negative cancel each other out. So you'll have e power 0 minus e power minus j omega minus 0.5 over j omega. That's the first term, right? Plus the second term would be, the first term will be e power minus j omega 0.5 minus e power 0 divided by minus j omega. Okay, which will be equal to e power 0 is 1 minus e power negative negative is positive, so j omega 0.5 omega times 0. Okay, let's say 0.5 omega, it's better in writing. J 0.5 omega over j omega. Let's take this negative up, so it becomes minus e minus j 0.5 omega plus 1, which is equal to 2 minus e power j 0.5 omega minus e power minus j 0.5 omega over j omega. And I'll leave it here. You can further simplify it if you try to convert it into a sine function, but I'll leave it there. So this is your x of omega. Similarly, following the exact same rule, we can find for this one, which is x of omega is equal to the integral from minus infinity to infinity x of t e power minus j omega t with respect to t. Again, we have the exact same process. We have two parts, from minus infinity to 0, from 0 to positive infinity. And why we're saying from minus infinity? Because this is an exponential, so it doesn't have an exact start point in time. So this will be from minus infinity to 0. The value is what? E of t, e power t, e power minus j omega t, plus the integral from 0 to positive infinity, which is t e power minus j omega t dt. How do same denominator, نفس المقام a e, sorry, we'll just add the powers, so it becomes a more simple function. So from minus infinity to 0, we have e power t plus j omega t, right? C or t minus j omega t. This is the common term, right? We can also take t out, and we'll say 1 minus j omega multiplied by t. So it becomes a single function, okay? Plus the integral from 0 to infinity of e power 1 plus j omega multiplied by negative t. Clear? So we just added the powers. Now it became a simple exponential functions. Just a moment. Okay. Which is equal to what? The exponential integration is the same exponential function divided by the factor 1 minus j omega from minus infinity to 0 plus the same function divided by the factor of t, which is minus 1 plus j omega from 0 to infinity. And we have to substitute limits in place of a variable. So it becomes e power 0 minus e power minus infinity over 1 minus j omega. That's the first limit, right? Plus e power, because here we have negative sign, it becomes minus infinity minus e power 0 divided by minus 1 plus j omega. Correct? E power minus infinity is what? 0. Any number to power minus infinity is 0. So this term is gone and this term is gone. E power 0 is 1. So 1 minus j omega plus minus 1 over minus 1 plus j omega. So these cancel each other out, right? So it's equal to this, right? This can be again further simplified if you want to convert it into a single complex number, but I will leave it at here. Is it clear? Any questions so far? Now, just to highlight a few things, I understand that there will be a challenge when you're integrating a lengthy function. So it's very important that you write detailed steps. And that's why it took time to write detailed steps for you, because when you skip steps, that's when you start missing numbers or missing signs or missing multiplying a factor and so on.
دكتورة
Yes.
يعني الحين بيجينا سؤال من هذا ولا كل هذه الأسئلة نفسهم بيجي؟
كيف؟
الحين من كل بارت بيجينا سؤال أو
Yes.
كل هذه الأسئلة بتجي؟
شوف الاختبار 4 أسئلة. You have 4 questions. Okay?
أعطيتينا عندك 16 سؤال دكتور.
ها؟
16 سؤال ما لدى الريفيجن والريفيجن الماضي ولا كم؟
Okay, let me finish what I'm saying and then I'll answer you, okay?
إن شاء الله.
So back to what I was saying, if you write more steps, you'll give me chance to mark every step that you do. Even if you have a partial mistake, it will be there. The other thing is when you write the steps, let's say if you notice part 2 depends on part 1, part 3 depends on part 2. So if you make a mistake in part 1, your next answers will be wrong as well. But you'll not lose marks in part 2 and part 3. You'll only lose marks in part 1. If your answers follow the same rules, okay? So that's why I'm writing in details. I'm giving you the detailed answers. I want you to give me the same way in the exam so I can support you that way. Okay? Now, the exam will start at 10 a.m., I think. So I'll be here all week. If you have any questions until Thursday, I'll be here. If you have any questions, email me. If you need support, maybe we can make an online session. Just make sure you understand the steps. If you don't memorize it, just understand it. Okay? And if you have any question, I'm here to support. Now, for the person who's asking about the questions, شوف الاختبار 4 أسئلة، بس لو سمحت لو طلعت على المراجعة حتلاحظ إنه الأسئلة متشابهة، فلو سمحتوا يا جماعة نفكر شوية يعني نشوف الأسئلة والمقارنات. أوكي؟ يعني هما كل سؤال بتلقى سؤال نفسه لكن بصيغتين، مرة مثلا low pass، مرة high pass، مرة series، مرة parallel. إذا فهمت الأول طبيعي حتفهم وتحل الثاني. أوكي؟ فالهدف من الأسئلة والهدف من المراجعة ليس إعطاء أسئلة الاختبار. الهدف من المراجعة دعم الطالب إنه يكون مستعد لنوعية الأسئلة وفاهم عشان يدخل الاختبار ويحل بفهمه. أوكي؟ تطلعوا على الأسئلة، إذا فهمتوا المراجعة أموركم طيبة في الاختبار، لأن المراجعة بتغطي كل المقرر وبتغطي كل أساليب الأسئلة. ف if you understand it clearly ما عندكم فيها مشاكل، أموركم طيبة في الاختبار تماما. أوكي؟ أنا طول الأسبوع إلى يوم الخميس موجودة. إذا الخميس كده بس إذا أرسلت لي إيميل بكون موجودة أنا. موجودة دائما يوميا أنا موجودة. لا ما للساعة 6 للساعة 4. بس إذا عندكم حاجة محتاجيني ل6 ارسلوا لي إيميل بجلس لكم، ما عندي مانع أنا. أوكي؟ ها أونلاين any questions؟
بس أول سؤال.
أول سؤال.
تفضل. نفس المراجعة الماضية بس فيهن اختلاف بسيط، صحيح؟
الإيه؟
الأسئلة متشابهة لطريقة الحل.
أيوة الأسئلة متشابهة. المراجعة الماضية تقصد الأسبوع الماضي ولا تقصد السمستر الماضي؟
لا لا لا، الأسبوع الماضي.
لا الأسئلة الأسبوع الماضي كنا بنناقش لابلاس ترانسفورم. الأسبوع ده الأسئلة هي فيها لابلاس صح، بس بتتكلم عن الفلترز تحديدا.
بس الأسئلة قريبة من بعض.
كيف قريبة من بعض؟
أول سؤال وثاني سؤال نفس قريب.
أول سؤالين في المراجعة دي نفسها تقصد؟
أيوة.
أيوة الأسئلة قريبة، يعني أول سؤال كان الفلتر بس لو باس، والسؤال الثاني كان هاي باس، نفس الأسئلة.
تمام.
أوكي.
شكرا.
عفوا.
دكتور من فضلك ممكن تنزل الأسئلة بدون الحلول؟
بدون أوكي تمام.
البارت A والبارت B من فضلك.
أوكي إن شاء الله.
وبعد في قوانين حفظ على ما أظن.
شوف القوانين الرياضية، قوانين الرياضيات اللي قانون التكامل مثلا ما موجودة في الفورميلا شيت، لكن الفورميلا شيت نفسها موجودة عندكم في الموديل، فوانتوا بتذاكروا اطبعوها وشوفوا القوانين إذا موجودة خلاص، إذا ما موجودة معناها احفظوها، لأنه هي نفس الفورميلا شيت اللي في الموديل حتكون عندكم في الاختبار.
خلاص طيب، جزاك الله خير.
Any other questions؟
هذا متى بينزل دكتورة هذا الريكوردينج؟
الريفيجن بنزل لكم النوتس، ممكن انزلها اليوم. الفيديو حسب اذا وصلني قبل نهايه اليوم بحاول ارسل لكم، او في اسوأ الفروض بكره الصباح، لانه احيانا بيتاخر الفيديو.
ممتاز، لأن علشان الوقت بعد.
اوكي. النوتس بتنزل اليوم اكيد، الفيديو اذا تاخر بينزل بكره.
ما مشكلة، النوتس كفاية.
Any more questions؟ طيب everyone، السلام عليكم وموفقين بإذن الله.
عليكم السلام. شكرا دكتور.